morning to all of you. Today, our group is going to present a presentation on the topic latent heat of fusion. First of all, I would like to ask you, what is melting point?
Melting point is the temperature at which any solid substance melts and changes into liquid at atmospheric pressure.
So let's learn more about melting point by Hani.
When we increase the temperature of the solid, the kinetic energy of the particles will also increase. Due to the increase in kinetic energy, the particles start vibrating much faster. A stage has been reached when the solid melts into the liquid. The temperature at which the solid then completely melts into the liquid is known as its melting point. The melting point of ice is 237.16 Kelvin, which is equal to 0 degrees Celsius. The melting point indicates the strength of the solid to melt into the liquid.
Fusion being the changing of solid into liquid on heating. So let's learn in detail by both.
The process in which a solid changes into liquid is called melting or fusion. The fusion of a substance, also known as latent heat of fusion, is the change in its enthalpy resulting from providing energy, typically heat, to a specified quality of the substance to change its state from the solid to a liquid at constant pressure. This energy includes the contribution required to make room for any change in volume by displacing its environment against ambient pressure.
So now, as you all know about what is fusion, so I would like to ask, what do you all know about latent heat?
The word latent is hidden.
So let's learn in detail what is latent heat by Anand.
Latent heat means hidden heat. The quantity required to convert 1 kilogram of solid into liquid is known as the latent heat of fusion. I would like to ask one question. What is the quantity which shows that with this latent heat of fusion?
So now, I and my friend Nancy will perform an activity to make you all more clear about what is latent heat of fusion and melting point.
First, we are taking a tap stand and we are attaching the thermometer. You can see it's a tap stand and we are attaching the thermometer to it. So I would like to ask, what type of thermometer is this? Okay, on Celsius scale. So in this experiment, we will notice what is the melting point of ice, and we will notice after every second the temperature remains constant.
So now, before starting our experiment, we will like to take some precautions. We will use a good quality of thermometer. The eye level should be at the mercury level so that there will not be any mistake to take the readings. And the thermometer, the thermometer should not touch the wall or the bottom of the container. So as then it will read the temperature of the beaker also. So now we will take a beaker filled with ice which is formed from distilled water. So spread the thermometer in it.
Dip the thermometer so as it is surrounded by ice.
Should be straight. So it will help them. Have you seen the least count of the thermometer? Yes, good. So what's the reading now?
8 degrees Celsius.
8 degrees Celsius.
So
We will note the temperature after every 30 seconds.
Now, Madam, please note the time. 5.
So it is going down because the thermometer was at room temperature earlier. So now it is taking the temperature of the ice.
Now again we will note the temperature.
It's 4 degrees Celsius.
4 degrees Celsius. We can see that the temperature is constantly moving down and it is taking the temperature of the ice. We will know the temperature till it comes to 0 degrees Celsius.
Now
Now
it's
it's
2.5.
2.5. We can see that it is
अब बीच में कैसे डालें? सर आपने
It's been 30 seconds. It's 0 degrees Celsius.
0 degree. Temperature is reached to 0 degrees Celsius.
after
It's minus 6 degrees.
Now it's been 30 seconds. Now it's 0 degrees Celsius.
Again it is 0 degrees Celsius in spite of passing 30 seconds.
now again we will note the temperature.
It's 0 degrees
0
Celsius.
degrees Celsius.
So I will ask a question to you. We from this activity we conclude that the melting point of ice is 0 degrees Celsius. Now I would like to ask a question. Ice is solid, you all know.
So you have
So,
just a moment, I just wanted. You are saying that 0 degrees Celsius is the melting point of the ice.
because it remains
Okay.
constant.
The temperature remains constant, but have you seen that ice has started melting and it has been converted into water? Have you noticed that?
Yes.
Yes, good. Now you continue.
So you know ice is a solid. So I will ask, when a solid melts, its temperature remains the same at 0 degrees Celsius. So where does the heat energy go? Yes,
The
Abhinav?
heat energy which we provide to the solid is used to overcome the forces of attraction.
Between the particles.
So now, are you able to understand why ice at 0 degrees Celsius is more breathable than water at 0 degrees Celsius? This is due to the reason that water do not absorb any latent heat from the substance, but ice absorbs 3.34 into 10 raised to power 5 joules absorb latent heat from the substance. That is why it is more breathable than water. So now it's this time.
Is there any other activity you want to perform?
Yes. It's nice.
Now we will whole water in one hand. So now Matthew, how are you feeling? In which hand you feel more?
Ice is more effective than water as they are on the same temperature.
So now you are able to understand the difference.
Yes, because of the latent heat, the ice absorbs the latent heat from our hand, but water has already does not absorb the heat from our hand. That is why it feels cold.
So now we will
Like to ask some questions. So you can recap all the points that we are studied in our experiment.
which is the heat per unit mass required for a substance to gain pressure? Okay, right. Where do ice and water coexist under atmospheric pressure?
Yes.
What is the latent heat of fusion of ice? What is the melting point of ice? At 0 degrees Celsius, the physical state of water is observed as?
Okay, Nandini.
Which is more effective, water at 0 degree or ice at 0 degree? You have already studied. Anjita?
Ice at 0 degree because it absorbs the heat from that.
Yes. When a solid melts, its temperature remains the same. So where does the heat energy goes? So now we will recite a funny poem on the 3 states of matter: solid, liquid and gas. The 3 states of matter are solid, liquid, gas, solid, liquid, gas, solid, liquid, gas. All day long, a floor is a solid. It does not change its shape. It cannot move around. It stays in one place. Your desk is a solid and so is your chair. Just look in your classroom, they all are everywhere. A water is a liquid. It moves quickly. We say that it flows. From one place to another, how quickly it goes. We know that movements are easy to see. They have no shape of their own. They are not like you and me. Air is a gas. We cannot see it. That's true. But often we feel it in many things that we do. Without it, we would be in big trouble. The 3 states of matter are solid, liquid, gas, and solid, liquid, gas. Thank you for listening to our presentation.